In this video, we'll prepare to prep for the graphs of polynomial functions. Now, when we're looking at various properties of the graphs of polynomial functions, one of the first things we got to do is look at the x and y intercepts of the graphs of polynomial functions. Now, a reminder that the y-intercept is the point at which the graph crosses the x-axis. And the way you find that is to set x equals to 0 and solve for y, or find what is the value of the function when x is 0. So for a couple of examples, let's say if you're given the function f of x equals to 4x cubed minus 2x squared plus 5x minus 3, and you're told to find the y-intercept, well, again, what you do is you plug in x equals to 0 into the function. So we plug in 0 in for x, so we get f of 0, and that would be just 4 times 0 cubed minus 2 times 0 squared plus 5 times 0 minus 3. And then, well, the first three terms are all just 0, right? Because 4 times 0, 2 times 0, 5 times 0, those are all 0. And so the value of the function when x is 0 is just negative 3. Now, remember, that tells us that, for one thing, is that one of the points on the graph of the function is when x is 0, y is negative 3. So we have the ordered pair 0, negative 3, so that would be the y-intercept of the graph of the function. Now, it's nice when it's all written out that way, because really the y-intercept is just the constant of the function. Now, sometimes the polynomial function may be in this factored form, like g of x equals to negative 2 times x minus 2, that quantity squared, times x plus 1, that quantity cubed. So again, to find the y-intercept, what we do is we plug in x equal to 0. So we have g of 0. So that would be negative 2 times 0 minus 2 squared times 0 plus 1 cubed. Now let's see, so that would be negative 2 times the quantity, well, 0 minus 2 is negative 2, so that would be negative 2 squared. 0 plus 1, that's 1, so that would be 1 cubed. 1 cubed is just 1, negative 2 squared is 4, so this will be negative 2 times 4, which would be negative 8. So this tells us that the y-intercept of the graph of that function is 0, negative 8. So like if I wanted to graph the function, we at least know that 1 point 6, 7, 8 is the y-intercept, which is that point 0, negative 8. Now, an even more important thing when you're talking about the properties of the graphs of polynomial functions is needing to find the x-intercept, or x-intercepts, because there could be more than one for a polynomial function. Now remember, the x-intercept is the point at which the graph crosses the x-axis. And what you do is you set y equal to 0, solve for x. Now what that would mean is you set your function equal to 0, solve for x. Now, for this first example, when we have f of x equals to the quantity 2x plus 3 times x minus 3 squared, this polynomial function is already in factored form, so that makes it a lot easier to solve for x. So we set our polynomial function, the 2x plus 3 times the x minus 3 squared, set that equal to 0. Now remember, by the zero product property, if we have a times b equal to 0, then either a is 0 or b is 0. So if 2x plus 3 times x minus 3, that quantity squared, is equal to 0, that means either the 2x plus 3 equals to 0, or x minus 3 quantity squared is 0, and if that quantity squared is 0, that means that x minus 3 must be 0. So then you solve these linear equations separately. Like for the first one, I'd subtract 3 from both sides, so I get 2x equals to negative 3. Divide both sides by 2, you get x is negative 3 halves. And for the second equation, add 3 to both sides, you get x equals to 3. What this tells us is that the two x-intercepts for this graph of this polynomial function are at the points negative 3 halves, 0, and at 3, 0. Now, sometimes the polynomial function may not be factored, and many times that will be the case. So you do have to remember how to factor polynomials. So if you're having a tough time with that, I would definitely recommend reviewing some of the techniques for factoring polynomials. Now remember, one thing you would always do, so if we have the function g of x equals to 3x cubed minus 12x, that the first thing you always think about when you're factoring any polynomial is, can you factor out a greatest common factor? Do all of the terms have a factor in common? Well, in this case, we have 3x cubed, then 12x, so you can factor out a 3x from both of those terms. And if we do that, what would we have left over? We'd have 3x times the quantity x squared minus 4. Now, x squared minus 4, that's a difference of 2 squares. Remember, that's x squared minus 2 squares. So that factors to x minus 2 times x plus 2. Now, for finding the x-intercepts, again, we'd set that polynomial function equal to 0 and solve that equation. Well, if we have 3x times x minus 2 times x plus 2 is equal to 0, that means either 3x is 0, x minus 2 is 0, or x plus 2 is 0. So we divide both sides by 3 for the first one, so we get x is 0. Add 2 to both sides for the second equation, we get x is 2. Subtract 2 from both sides of the equation, we get x is negative 2. So our 3 x-intercepts occur at 0, 2, and negative 2, so the points 0, 0, 2, 0, and negative 2, 0 are x-intercepts. Now, we're going to find a lot of other properties of the graphs of polynomial functions, but a lot of the times we've got to first find these x-intercepts, because we could then look, okay, what happens to the far left of the furthest left x-intercepts, what happens to the right of the furthest to the right x-intercepts. We could talk about what happens in between the x-intercepts, but what we first got to do is to find the x-intercepts.